Welcome back, everybody. So today I have the great pleasure to announce Mirco Ravanelli. He is a postdoctoral researcher at MILA currently, but he will soon join Concordia University as an assistant professor and the University of Montreal as an adjunct professor. His main research interests are deep learning and conversational AI. So he is the author or co-author of more than 50 papers on these research topics. He received his PhD with cum laude, so with distinction, from the University of Trento in December 2017. Mirco is an active member of the speech and machine learning communities, and he is the founder and leader of the SpeechBrain project. And this brings us exactly to the title of today's presentation, which will be the SpeechBrain project. And Mirco, I'm really happy to have you here. I think it's really great efforts that you're doing here, and you're really doing a great service to the community with your open source endeavors. So this is why we welcome you here. I really look forward to your presentation, and the stage is yours.
Danke. Guten Tag. All right. So today I would like to introduce a little bit the SpeechBrain project, which is one project I founded, I'm leading. So it's very excited today to tell you what we are doing here. So SpeechBrain is an open source toolkit for conversational AI. So conversational AI is a kind of new terminology just to refer to machines that hopefully will be able to communicate with humans in a kind of natural way. And this is clearly a kind of major step in artificial intelligence. It's not just kind of scientific challenge, but it's also an industrial challenge. And as you can see, right, all the big companies made major investment in this technology. So you can see, for instance, that virtual assistants, automated call centers, chatbots, purchase assistants are nowadays everywhere. So, but yeah, this kind of technology poses remarkable scientific challenges. So as we will see, and as you probably know, building a conversational AI system requires combining several technologies, and all these technologies have still some kind of issues. For instance, if you would like to have kind of AI assistants with a speech recognizer or any speech technology, we know that these speech technologies might suffer a lot when dealing with under-resourced languages, dialects, environmental noise, or even accent. If we move on, we may have a dialogue part, and the dialogue part is even more critical because we may have lack of consistency, personality, empathy. And more in general, this kind of full, big, long pipeline of technologies suffers from big issues, big out of generalization issues. Like, for instance, if we train our virtual assistant or conversational AI agent to solve on some topic, and we talk to the machine on totally different topics never seen during training, very often we don't have a satisfactory conversation with the machine. So out of distribution is really, really a big topic here. And not just here, but in general in machine learning, but in the conversational AI is particularly important. Moreover, I see other big issues. So basically, beyond the pure scientific challenges, one big issue is that conversational AI is actually in the hands of few players only. And the reason is that there are important barriers that prevent this technology to be available to everyone. When I say available to everyone, I don't mean available to everyone as user, but available to everyone like developing and mastering the technology for creating new research or creating new services for users. And the main barrier is data. Big companies have data. Small companies, even us in the academic field, we don't have a lot of data. I'm here a little bit more optimistic than in the past. Like I see some growing open source projects that try to fill this gap, like for instance, the Common Voice one, but still data is a big issue. Even bigger issue is the computational resources. I know we are clearly going towards models which are bigger and bigger. Every time we have a bigger model, we have better performance. We don't know when this trend will saturate, but for now, training a really competitive model like Wave2Vec, for instance, is out of the possibility of many companies or academic labs. The other barrier is code. Big companies are not typically releasing their full code for conversational AI systems, so you cannot find the code for Siri or Google Home, etc. Instead, we would like to focus on that part and try to do our best efforts to break down this barrier and create an open source code for conversational AI. So what is SpeechBrain in practice? SpeechBrain is an open source, all-in-one conversational AI toolkit based on PyTorch. Our goal is to make conversational AI available to everyone. And in particular, SpeechBrain is designed to speed up research and development of speech, audio, and language processing technologies. So we try to design something flexible, easy to use, modular, efficient, and with good documentation. As I mentioned before, conversational AI are actually based on the combination of many different technologies. So this is just a possible example. We might have here we have an input as long recording. We may want to detect which part of this recording are speech and which part are not speech with a voice activity detection. Then we would like to recognize if some specific keywords are uttered, like Google or Siri, etc., that wake up the system. When the system is active, we may want to perform speech recognition to transcribe the request of the user. We may want to perform spoken language understanding to understand the meaning of this request. Finally, we would like to start a dialogue system and returning back to the users with a speech synthesis system. So this is just to give you an idea, but what is important here is normally in any conversational AI system, we have tons of different technology that you should kind of interconnect with each other. The good news is that most of these technologies are already available in SpeechBrain. For instance, until the spoken language understanding, we have good baselines, and for the dialogue part and the speech synthesis, we don't have something fully ready now, but there is work in progress. So one peculiarity of SpeechBrain is that we design it from scratch to support multiple tasks and multiple speech and language processing tasks. So we did that with the beginning, right? At the beginning, we say, okay, we would like to support complex chain of pipelines and how we designed the system. That was possible today just because all these tasks in the end are strongly interconnected because they share the same underlying technology, which is deep learning. So when I started working in this field, it was 10, 11 years ago. And the technology was actually very different. For instance, the dominant technology was in speech recognition, was hidden Markov models coupled with the Gaussian mixer models. For speech separation, speech enhancement, the dominant technology was based on signal processing. For voice activity detection, we were computing some kind of handcrafted features like pitch formats, and we were just combining them. Now everything is different because all these kind of technology can be implemented with neural networks. So we took advantage of that and we created SpeechBrain. We called this project SpeechBrain because we wanted something that, just like our brain, recognizes speech, understands its content, the language, but also understands some kind of meta information inside the speech signal, like the language, the emotion, the speakers, and finally will start a meaningful conversation with human. So that's why we called SpeechBrain. So there are few reasons why having a kind of single toolkit for managing all the complex pipeline of conversational AI system is valuable. First of all, this can really speed up research and development of speech technology. Like if you have kind of single project, single toolkit for all these technologies, you have the same coding styles, standards, and programming languages, so you don't have to jump from one repository to another just if you would like to change a task, like from voice activity detection to speech separation, for instance. And that saves you a lot of time. Another reason is that, within a single toolkit, it's significantly easier to combine all this, the technology involved in a conversational AI system. Also here, you don't have to, kind of put together different things, so everything is natural and you can do it. And if you can combine the technology, you can also, are encouraged to explore kind of novel techniques like transfer learning, joint training across all the tasks. You can eventually create, a kind of big differentiable computational graph where you backpropagate from the very end part, like a dialogue or whatever, and you backpropagate the gradient through the beginning of the chain until they input the waveform. So this is possible if you have a single toolkit. However, creating a single toolkit was the main challenge, right, of this project, because creating something which is modular, a multitask, is always a big challenge, even because the tasks that are involved in conversational AI system are many and different requirements, etc. So we put a lot of effort here to design something hopefully valuable for the community. All right. What you can do with SpeechBrain. So currently we support speech recognition. Here we have simple system based on RNN transducers. We have transformers, but we also have beam search plus language model, beam search plus transformer language model. So we have all the necessary ingredients to build a state-of-the-art speech recognition system. Then we have speech enhancement, which is about denoising and input speech. Also here we have several baselines, including like the recent metric gun plus and mimic loss. We also have speech separation, which is about separating speakers when they are talking at the same time. And here we have baselines like COMP-TASNet, dual path RNN, and also the recent SEP-former. We are also spoken language understanding baselines. So here it's similar to speech recognition, but instead of mapping from speech to text, like in speech recognition, we map from speech to a kind of semantic representation. And here we have baselines for some data sets that you find in the repository. We also address speaker recognition, which is about detecting speaker in a kind of speaker identification or speaker verification setting. We have standard X vectors, but also we have kind of very powerful system called a kappa TDNN that creates good, very accurate speaker embeddings. Finally, we have some simple baseline for speaker diarization, which is about the task is about detecting who speaks when, and we have system based on spectral clustering. We have much more than that. Actually, we now have baselines for speech translation, language modeling, language identification, sound classification, graphing to phoneme, multi-microphone signal processing, and also these days I'm working a lot on EEG decoding of brain signals. So we are creating a kind of general toolkit, and so other sequence processing tasks can be suitable for that. So that's why I'm also extending SpeechBrain to EEG signal these days. There is a lot of work in progress. Text to speech, as I mentioned, is something we would like to do. Also, music generation. We are going to integrate our toolkit with K2, particular for the finite state transducer part. We'll see more later. For what regard the performance, SpeechBrain is released with many recipes. With the term recipe, I mean all the needed steps, right, to train a model from scratch. So this term recipe is inherited from Caldi, and here we are basically doing the same. And yeah, the good thing is that we, for all the data sets that we are and tasks that we're providing, we have competitive or state-of-the-art results. For instance, here you can see like LibreSpeech, our best system, which is combination of W2VEC and CDC, which is 1.9% award error rate on Tescaling. We also have a lot of baseline for Common Voice. Here, Common Voice is much more challenging than LibreSpeech because we have accented speech, noise, etc. We have baseline for French, Italian, and English, and many other, German as well, and many other languages. Here we also have simple baseline like TMIT. We have like 8% word error phoneme error rate. We also have other tasks like speaker verification with VoxLab 2. We reach an equal error rate of 0.69. We have speaker diarization on the AMI dataset. Here we have 2.13 diarization error rate. We have the state-of-the-art actually in the voice bank dataset for speech announcement with our latest metric gram system, which gives a PSQ of 3.08. And also we have the state-of-the-art with speech separation, where our subformer reaches performance above 20 decibel on the standard Wall Street Journal 2 mix task. So yeah, the good news is that you can find at least kind of competitive systems in SpeechBrain. So few words on the design principles. So the first principle we had in mind is we want our code, our toolkit to be accessible. So we release it with a very permissive license, Apache 2, so you can use it for commercial and non-commercial uses, just like Caldi, no problem. Moreover, we want our toolkit to be accessible by everyone, including not just the very expert researchers or programmers or computer scientists or whatever, but also by hopefully early students and practitioners. So we try to consider a lot this educational purpose of Toolkit because this is an academic project, and I think as a professor, for me it's very important also to serve educational purposes as well, not just research one. We try to do our best to make everything as easy as possible. Of course, not always that easy, but we try to create a kind of modular code with modules which are that implement some kind of clear functionality and are easier to combine with each other. We work on a lean software stack, so SpeechBrain is directly implemented on top of PyTorch without nothing in the middle. And also we try to minimize as much as possible the external dependencies to make everything as much as possible under our direct control. Another important principle that we follow is, we would like to promote open, transparent science. Ideally, we would like that in the future, all researchers will publish their results on open data and they release the code such that the community can replicate the number and take benefit of that. So yeah, we are a big fan of this, and what we have done on our side, we release the code, we release not just the code, but also pre-trained model and all the information that can help users replicating the numbers that we achieved with SpeechBrain. So yeah, that's something important, and we encourage also the community to follow that practice, like write a paper, publish as much as possible on open data, and release the code publicly. So that's I think a good practice that's I strongly believe that the community should follow for the benefit of everyone. So how can you train a model with SpeechBrain? So we will see maybe later, but we have a lot of recipe stuff. But in all the cases, you can just train a model with these simple instructions: Python, train.py, which is the experiment script, and hparams file, which is the hyperparameter file. So let me take a look at quick look at both. So the hyperparameter file is something that we designed with an extended version of YAML that we call hyperpyaml. So in SpeechBrain, we wanted to avoid kind of plain list of hyperparameters where we don't really like this kind of plain list of hyperparameters that we often see in machine learning projects, because you don't really know who is using this hyperparameter where. So in SpeechBrain, instead, we created this hyperpyaml where you always have a connection between the hyperparameter and the object or function, the class or function using it. For instance, here is an example, like the nmel parameters 40 is used by lobes, by the class that you find in SpeechBrain, lobes, feature, MFCC. So you always have a visible connection between the hyperparameter and the class or function using it. And that's, I think, increases a lot the transparency and makes everything easier to debug. But the other big advantage of that is that when we read a kind of YAML file like that, we can already initialize these objects. So and when you're going to use these objects, you already have it initialized. So you don't have to write yourself the boilerplate initialization code. So yeah, the philosophy here is that the hyperparameter file defines the functions or classes that we are going to use, while the train.py instead defines how to combine these function or classes defined in the hyperparameter file. So maybe we will see quickly some code later, but here the main idea is that we wanted something where all the main computations that we think users will modify the most are visible, like we have visible the forward computations that goes from the waveform to the output probability. The compute objective computation are visible, and also the data processing computations are visible directly here. So people don't have to jump. Nobody knows where in the code. They just see at least these important computations there. And to make everything easier, we create kind of special class called brain, which help orchestrating the training loop. Maybe we'll see later quickly an example. But we don't have only kind of training facilities, we also put our pre-trained models on Eigenface, and we couple them with easy inference functions. So right now on Eigenface, we have 31 models, and you can perform inference with just 3 lines of code. Like if you would like to do speech recognition using one of our models, you can just tell where the model is stored, and if you like to transcribe the file as some file, you just call transcribe file, and you have your output. And this is basically what you can do for speaker verification, speech separations, and many other tasks. So we don't only have the pre-trained models, but we also have coupled the pre-trained models with easy inference function to allow everyone to use them quite easily. I started this project, the development of this project was started in February 2020, which really at the beginning of the pandemic. So actually I was able to, find some funds for this project. I got some interns here in Montreal working on that. But at some point, the pandemic exploded, and we had to switch from physical work to remote work. And that is, in the end, it wasn't that bad because we were able to structure the project to be kind of a remote working friendly, and now we can go ahead with this. So yeah, we worked very hard with this team for more than 1 year. In March 2021, we released the first version of SpeechBrain, and from now on, the project is growing very fast. Just a few numbers: we have 18 core developers. Yes, maybe 60. This is not even updated, but we have more than 68 contributors, 3.3 K stars on GitHub, maybe now 3.4. More than 500 forks, 73 training recipes for 23 datasets, 31 pre-trained models on Eigenface. But the thing that I'm more proud of is that we have contributors from all the continents. And when I joke, I say the sun never sets on SpeechBrain, just because it's true, right? So when I don't know, I go to sleep, someone in, Taiwan or East Asia wake up, then there are also the European guys waking up, and then I wake up again and I see the work done by the others. So it's pretty exciting, right? Working in this way. So you have non-stop work basically if you structure a project in this kind of international way. So yeah, maybe since there is some time, let me give you a very quick tour of the toolkit and the available resources. So let me see here if I can. Let me do here. So if you do SpeechBrain, voila, you can. This is our website, but if you go in Google and you type SpeechBrain, you can find the project quite easily.
We will also post the links with the video.
Okay, thank you very much. So basically, this is our website. You can find here key features of the projects. You can find the code here and tutorials here, documentation here, etc. As for, let me start from the code. Code is here. It's a GitHub repository. You can find here basically. All right. Sorry. Okay. Let me. Okay. Don't see. Okay. Anyway, yeah. You can see here. There is the repository. The most important code is written under SpeechBrain. So you can find here all the needed library to implement neural network, signal processing, and all the needed things. You can also see the training recipes here under recipes. Here we have a list of datasets that we support. If you go, for instance, in LibreSpeech, you can find here LibreSpeech ASR, sec to sec, And here you can find an actual training recipes, which is composed, as mentioned before, by an hyperparameter file and a train.py file. So if you open this hyperparameter file, you can see something similar to what we have done before. We have seen before. You can see that, for all hyperparameter for all hyperparameters, you can see the corresponding, function or class using it, etc. So we here define all the important computations, and then in the train.py, which is this script here, you define how to combine these modules. So here you can see this is a pretty complex system because we are doing sec-to-sec training with beam search, language model, external language model, multitask learning, CTC plus sec-to-sec. So pretty complex architecture, but 300 and more than just a bit more than 300 lines you can have your system. And as I mentioned before, you can see here the most important computations are visible here. Like here we expose the forward computations, like that goes from the batch to the output probability, like we do here, like feature data augmentation, feature extraction, normalization, encoding, and all the needed computation for the forward computation. Then we define here the compute objective computation that goes from the predictions to the loss, like so here is the final loss of the system. And also we expose also data IO preparation things, like here we specify like how to read input waveform, and here the text pipeline we define how to process the labels in the way that we need. So you can have all these kind of computations already exposed. So that's the same for all the recipes. So you can see here that it supports many datasets, but in all the cases you have hyperparameter file and experiment file. Then there are many things here you can really take a look if you want, and we have other things, but the most important things are the recipes and the main folder. So here you can find if you appreciate actually our effort for the community, feel free to start a project to help us gaining visibility. All right, so okay, sorry. Here we have a Discord channel for chatting with the community. You can find the documentation here. Let me just give you an example. Documentation like core library, I don't know, neural networks, CNN, or whatever. Here you have all the functions, like in this case, syncconv, short description of all the functions, like this, and very important for all the class or functions, we are releasing and working example. So we are as aligned as possible to the good documentation provided with PyTorch. So we did that on purpose. So almost all the functions that you find here follow this scheme. And we found really very important to provide a working example every time, because this helps users understanding what's going on and what is implemented in one particular function. So that's super important, and we try to be very consistent with that. So yeah, this is the documentation. You can also take a look, for instance, at our tutorials. We have many of them. Tutorials do not just tell you how to use SpeechBrain, but they tell you also more in general. They try to educate users about the speech technologies. So, like in SpeechBrain Basics, you find basic things, and if you open like this, what I can do with SpeechBrain, for instance, you can see, for instance, how to use some of our pre-trained model here. Again, there is a lot of explanation how to install, etc. Here is the way the few lines that you need to train to do inference on a model. Like if you have these input signals here.
The birch canoe slid on the smooth planks.
Can you hear it? I hope you can hear the signal, and this is the transcription. We have speech recognition also in French.
Mon chien est le plus beau.
Mon chien est le plus beau. And also here we have the transcriptions. Italian is me.
Buongiorno a tutti e benvenuti a bordo.
And here we just, here what we do, we just load the model and we perform transcription. We have Mandarin as well. And they told me that this is correct. And these days you don't really need to know the language to develop speech recognition system. So we develop also a new system for language spoken in Rwanda called Kinyarwanda. Nobody in the team was able to speak this language, but we were able to build a speech recognition system because just need input data, output data, and SpeechBrain will map you. We will find a kind of meaningful mapping between the input data and the output. So this is Kinyarwanda.
Abamugariye ku rugamba kubona insimburangingo.
Which is actually correct. Then we have other tasks like speech separation. This is one example. Here we have two speakers speaking at the same time. This is the input of the system.
My father has revealed the culprit name.
And this is the output that we obtain with our SEP former, the best model we have.
My father has revealed the culprit name. The birch canoe slid on the.
So in this case, the separation looks really good. And, this is not the target. This is actually the separated signal. And then you may have other system like speaker verification, etc., etc., etc. So yeah, you can take a look at the tutorial and see and use yourself. So let me finally, let me go back here. So here we have most of the models are available on Eigenface. Here you can see many of them for all the things like speech separation, speech recognition, and whatever, Voxlingua, language identification. Let me just try this, which is pretty. So here is our instructions on how to use the pretrained model. And most of the times you also find here kind of API that allows you to use the model on the fly. Like, for instance, let me try to say, so here is a language identification system. So the input is one short audio clip, and the output is the language corresponding to this audio clip. And we here support 107 languages. So let me try to record something. Ok, in questo momento sto parlando una lingua. Potresti per cortesia dirmi che lingua sto parlando? Grazie. Ok, let me see. Ok, in questo momento sto parlando. So that was actually Italian. The first time here, it takes a while because it has to download the model and use it. So let's see how long it takes, but okay, it is done. So here you can see it is recognized as Italian. Second is Spanish, so maybe recognize some kind of Latin background. I can try in English, like for instance, like, hi everyone, could you please tell me which language I'm speaking? Thank you very much. Hi everyone, could you please tell me which language I'm speaking? Thank you very much. So look at here, so like it recognizes English, but also the second best language is Portuguese. Maybe it is kind of recognizing kind of Latin thing and Latin language, Latin accent in the background. So yeah, feel free to use it. It's pretty impressive. I tried with many languages that you can find here, just feeding signals in these languages, and most of the time it was working correctly. So this works like as a 94% accuracy on short audio clips on the 107 languages. So I would say pretty superhuman. I don't, at least in this task, because I don't know humans able to recognize so many languages that precisely. So feel free to have fun with that and let me know. So yeah, here we have many other things. I don't have the time to go through all of them, but you are encouraged to take a look. Okay, so let me go back to the presentation for the last part of the talk. So many of you may have this question, so how SpeechBrain is compared with other toolkits. So SpeechBrain versus FairSec, the comparison here is, FairSec is actually a sequence-to-sequence processing toolkit. It includes many things, including transformer, wave-to-vec, and many other things. While SpeechBrain is actually a little bit more than a sequence-to-sequence toolkit, because we also support other tasks like regression tasks, like speech announcement, speech separation, classification tasks like speaker recognition, and also clustering and signal processing techniques. So another very good toolkit that you may want to try is Nimo. Nimo is a toolkit developed by NVIDIA, and it has this kind of, it's very good. I mean, you can do many things with it. It has kind of industrial orientation. You can use it you have kind of the shelf ready-to-use models like Jasper, QuartzNet, and CitrusNet, which are pretty valuable. So the main difference with SpeechBrain, I think, is that SpeechBrain also provides a lot of ready-to-use models, but is more focused on the research and education part, while Nimo could be probably more suitable if you're looking something, efficient, ready to be used in a kind of industrial pipeline. The most similar project is espinet. Espinet, the main similarity is that espinet and SpeechBrain are both academically driven, which is good and bad. Good because bad, let me say bad before, because we don't have the amount of money that a company can put in, but good because we can be very transparent with respect to the technology. So we are not trying to push any particular model that's the company developed. We hope that with the help of the community we can be transparent in terms of the progress, and we can hopefully implement models just because they work well and not because there are other interests. So one difference with SpeechBrain is that SpeechBrain started as a kind of end-to-end speech recognition library, and they progressively grew to support different tasks, while SpeechBrain is actually designed, is a kind of it's a more recent project, and was designed from scratch to address different tasks. So this means that combining technology with SpeechBrain should be relatively easy. So yeah, question here, is it better as SpeechBrain or espinet or FairSec or Nimo? So this is up to you, really. My suggestion is try some of them and use the one that best fits with your needs. So there's value in all of these toolkits. So just use the one that you like more, no problem. What's next? So we have big plans for the future. We would like to dive into the small footprint, real-time, low latency speech processing world. We didn't address so far, but it's very important. It's a task of very there's a lot of interest, not just scientific, but also industrial interest on that part. Now our goal is to scale up to a lot on multiple languages. Now our goal is to train a kind of single neural network that is able to perform speech recognition on a lot of different languages. We are going to work more on text-to-speech. So this part is a little bit missing these days, but we plan to spend time on that. Especially, we would like to develop multi-speaker text-to-speech. And as I mentioned before, we would like to complete the pipeline. We need to have the dialogue part, and this is something we will hopefully address in the near future. And very interesting also, we can do music processing. We only have right now one simple baseline for kind of symbolic music generation, but this is another very interesting word, and we would like to put efforts on that. If you would like to hear more, to read more, actually, there is this paper that you can find on arXiv. And also, I would like to thank the sponsors that helped me a lot, like the funds from sponsor. We're able to hire amazing interns that were able to work on that. So Eigenface, Samsung, Dolby, NVIDIA, Nuance, and via Dialog. I have to also say that we are always looking for new sponsors. The project is going to be very big, and we are looking not just sponsors, but also new collaborators. And if someone in the audience is interested to collaborate, of course, this is really, really welcome. So managing this project is not easy. There are many things to do, and the only way we have to succeed is to build a strong community around of that. And this is what we are trying to do. Here, let me announce that thanks to Eigenface, which is one of our sponsors, we are able to now hire a research engineer. And if you are interested, or if there is someone that you know that could be interested in this position, please send an email here at speechbrainproject@gmail.com. Of course, I have to thank our institutional partner, particular MILA and Avignon, that work very well together to improve the toolkit, but also Cambridge, Sherbrooke, and BioSFP Lab in Taiwan. And of course, a big thank to the core development team, which worked so hard. I never worked that hard in a project, but I was very excited, and we are very happy to have released something helpful for the community. And also, I have to thank our scientific advisors, Joshua Benjo and Renato De Mori. That's all. Very happy to stop here and reply your questions.
Mirco, this was an awesome presentation. I enjoyed it very much, and I have a small round of applause for you. I hope you can hear that. Unfortunately, pre-recorded.
Oh, thank you. Yeah, I can hear now, yeah.
Yeah, this is what you would get in Germany, some heavy knocking on the table. So
okay.
Great.
Thank you.
I really liked the talk. This is awesome work, and I must admit I'm also a big fan of open source and open data projects. So SpeechBrain is very much what I really also like, people that I know and our PhD students to engage in. So this is a really, really great effort, and I think it's great work that you're doing. So
thank you.
It's amazing. It's also amazing to see that you're building this entire community and you have so many contributors. So how do you get new contributors on board? Do you have a kind of strategy to get them abroad, or how does that work? I mean,
well,
one thing is excellent presentations like the one you just did, but are there more tricks than that?
Yeah, actually, we try to start a discussion with the community. We have this kind of chat that we're communication channel, right, with all the users, and we share there what we think is important, and with the hope that someone will contribute and will help us contributing. What is happening in reality is that we don't have to do special efforts. Most of the times we wake up in the morning and there is kind of new requests from one user fixing one issue, or extending one baseline to another language and things like that. So things are going on even without too much coordination. Of course, the preferred way is to contact the core development teams, talk to each other, about what could be important to do, etc. So coordinate a little bit more. But in practice, I see that things happen, just happen. So people just notice an issue in the code and they just fix it on the fly, and they share the fix, or they just share their work without telling us nothing in advance. So
cool. That's really great. So you also have a large list of sponsors, which is also very impressive. Is this the same, that they just approach you and say, how can we support your project, or how do you get sponsors on board?
So sponsors here, actually, there is a mix here between new sponsors and old sponsors. So Samsung, Dolby, NVIDIA, and once we're old sponsors like Eigenface and Viadalog are new sponsors. So here we really need sponsors, because managing a project that is getting that big is so hard. You need students, you need, as I mentioned before, a research engineer to manage the code, improve it progressively. So what we do here is just ask the contacts that we have and see if we can convert. Most of the time we don't converge to nothing. Sometimes we are more lucky and they give you a small amount of money to hire students. So we're not talking about, huge amount of money. We are talking about donations to hire students.
No,
but it works.
I think it's very important. And also, let's say if I get approached by somebody, they say, what kind of software should we use by industry? And they said, look, SpeechBrain should look interesting. Are you interested in contributing, or how would you do that?
Yeah, we have always an open call for sponsors, right? So that's we are always looking for sponsors. If you go in the website, you can find the call for sponsors that we normally accept. So normally what we do here is we are mainly looking for donations from sponsors. So we are not really offering service like consultancy or implementing models specifically for a company, but we are mainly looking for unrestricted donation where they can give us some money to hire students working on the project, mainly on task of common interest. But we are not, in this moment, SpeechBrain is not a company, right? SpeechBrain is just an open source project, academically driven. Maybe in the future, we may want to offer more industrial services to the company that would like to use it, but right now we are really open source project only.
It's great to see you strive. It's great that you are so successful with contributors and sponsors. This is really a cool thing. So how many languages do you support in terms of ASR already? It seems that you have language ID 107, ASR.
Yeah, for language ID we have 107. But we just have this big neural network, that's able to recognize so many languages. That was actually done by an external contributor in Estonia that did this wonderful work. And for ASR, we don't have really so many languages. So we have Italian, English, French, Italian, German, Mandarin, Kinyarwanda, Korean. So we have like 7-8 languages. But now, and the reason is that we didn't want to scale up everything at the beginning of the project, because we wanted to scale it up only when we are reasonably sure everything is fine and we don't have to rescale again. So I think now we are almost ready to do the scale, and that's one of the direction I said for the future. We will like to massively scale up to new languages, and the way to scale up is very important. I think now there is evidence that you can even train kind of single big neural networks that is able to perform speech recognition in multiple languages. So this is probably the approach that we would like to follow, because it's more scalable than having tons of different models for different languages. It's more challenging, but there is evidence that this is actually possible these days.
Wow, impressive. So you mentioned that there's also two more bottlenecks. I mean, the software, of course, you're tackling this with SpeechBrain, and then there's also the data and the compute. So you mentioned the Open Voice project, right? Common Voice project, sorry.
Common Voice, yes.
And do you think this will solve the issue? And how will compute be solved? Do you have some ideas just by computers get more powerful?
For data projects, actually, very big problem, right? So there are big companies have privacy restriction; they cannot share the data, etc. So I don't think a common voice alone will solve the problem. Also, because common voice is just for speech recognition, where we want to do something more. But in general, I'm quite optimistic about that, because I see that there is a kind of multiplication of that open data set that are coming out every day, every week, or whatever. So common voice, in my opinion, is a very valuable one. There are many others, and they mitigate at least this big data problem that we have, like academia versus big players. What is more critical, in my opinion, is the computational barrier, right? Right now, like if you would like to train a wave-to-back system, for instance, very popular these days in speech, you cannot do in academia, right? So you need like, I don't know, 30, 40 or 60 GPUs for weeks, right? Or 2 weeks or 3 weeks or whatever. We are trying to replicate one these models, right? But we're trying to put together all the resources we have, in MILA, in France, whatever. So it's very hard to be competitive, or almost impossible. And for that, I don't really see a solution here. So the world is going towards more data, bigger model, and I'm not really optimistic in the short term about the computational bottleneck. So also because there is no competition in the market, right? So everything is in the hands of one player, which is NVIDIA, and prices are huge. Like one DGX server like costs more than my apartment. So I mean, it's really hard here to be competitive. I don't have any solution. Maybe it will be really great if in the future there will be some kind of fully open source project that also create a new hardware for doing deep learning in a very cheap way. But this is really, really much more complex than what we are trying to do at the code level. But yeah, I'm very scared about that, and I don't have the solution now.
There's some efforts like AI for EU that try to scale supercompute power across the European Union and make these sources accessible. But of course, it will come at a cost. You have to pay for the compute. You cannot do it for free. Maybe at reduced rates for academia, but it will still be expensive to train those models, even with such big initiatives. And I'm completely with you. Yeah, I don't see a solution as well.
Yeah.
In short term. So regarding data, do you think that anonymization can help us? So at least in the European Union, the data protection regulations are kind of a big hindrance of publishing data. Do you think that may help?
Yeah, that could work, or even more projects in which people, they just donate their data, their voice for free, like Common Voice could be good. Yeah.
Mm-hmm. Mm-hmm. Yeah. I was really stunned that you're also processing EEG data with SpeechBrain. So do you know which projects are currently running? Can you tell us maybe one or two examples where people are using this?
Actually, I'm leading this part because I'm getting interest more and more on the EEG part. Basically, here what we are trying to do is to connect SpeechBrain with the kind of standard EEG benchmark called MOAB. And essentially, what we are trying to do is to use the same techniques that we use for speech, but extend them for EEG. Because in the end, right, EEG is just very similar to multi-microphone signal processing, right? So we just have multiple channels and we can process them. So we are implementing new models like EEGNet, ShallowNet, PodNet, and also we are trying to use the same kind of models that we use for speech and use for the first time in EEG and see what happens. Well, it turned out that you can use SpeechBrain for EEG without too much trouble. So what we have implemented for the speech processing part can be most of the time used for the EEG processing part. And what we are doing now is to just do hyperparameter tuning and have competitive performance, but it's not that difficult, right? So if you're interested, there is a pull request going on SpeechBrain project where we actually work on this sub project.
I think that's pretty cool. So regarding the electrode setup, do you use covering the whole brain or only certain areas, or what's the current approach right now?
So here we are not doing the data collection ourselves. What we are doing is to just use a kind of common EEG data, like the one that I mentioned before from WAB. So we are not really doing the data collection ourselves, but we just create baselines from pre-recorded popular datasets.
Really cool. And I think there will be amazing results that will be produced with SpeechBrain. So this is a super cool project. I wish you all the best for this. I hope you can get many sponsors to support this. And I really appreciate that you could show all the functionality here. And I think your project really deserves many more contributors to support this. I think this is really important that such technology is available, open source and accessible. And it's really a great job that you're doing here.
Let's hope for the best.
Thank you very much for
presenting
here. I have another round of applause for you.
Sure.
Which I hope you can still hear.
Yeah, I'm here. No problem.
So thank you very much.
Thank you. Thank you very much.
All the best for the future.
Thank you.
Yeah, you've seen there was a very nice discussion after the presentation. I think this is really cool work that Mirco is doing here, gathering the entire community to help building open source software. I think that's really something that we need more of. And I really hope that this project will continue for a long time and establish software for every one of us. So of course, this doesn't end the discussion. I of course have all the links that he presented here in the description of the video. And we are both active on social media. So if you want to connect, ask additional question, either use the comment function here under the video or directly approach us on Twitter. And I think there are many, many more things that can be discussed regarding SpeechBrain. So I hope you liked the presentation as much as I did. And I'm very much looking forward to seeing you in another episode of Beyond the Patterns.